Hello everyone, hope you're doing well today. So let's go ahead and let's go over the answers to these 5 problems that we need to solve using the factor label method. That method's also called the unit analysis or dimensional analysis method. And in that method we have a measurement in a particular unit and we needed to convert it to a different unit. And that's going to be a skill that we use quite often in this as we progress through this course. Now the units that chemists generally use are really not gallons or miles, but the process of converting a measurement in those units or in any units is the same when using the factor label method. So I think it's important that you be able to do problems like these 5 for the upcoming quiz and exam. So let's jump in and let's talk about how to do them and let's go over the answers. So for number 1, converting 16 gallons to liters, I write down the number in the unit that I'm given. I give myself some space to work the problem. I write down the desired unit, which in this case is liters. And I see from my table of equivalencies that obviously you can use on quizzes and exams that 1 gallon is 3.785 liters. So I write down that conversion unit as a ratio or as a fraction, and I write it so that my gallon unit, my 1 gallon unit, is in the denominator, and that unit can cancel with my gallon unit in the numerator with what I'm given. I have liters in the numerator up top, which is great because that's the unit that I want. So when multiplying those two numbers and rounding to 2 significant figures, and I use 2 significant figures for my final answer because that's what I'm given in the problem here. My final answer is going to be 61 liters. So only one conversion factor was needed to solve that problem. Similar situation for number 2. I have to convert miles to feet, write down the information I'm given, give myself some space, write down the unit that I'm looking for, which is feet. There's 5,280 feet in 1 mile. Again, writing that conversion factor as a ratio, as a fraction, so that my units cancel appropriately. I'm left with feet, with foot in the numerator. And that's what I'm looking for. So when multiplying those two numbers together in your calculator, you should get 68640. But again, remember, we need to use the rules for rounding and significant figures for final answers. We have 2 significant figures in our given. Conversion units have infinite sig figs, so my final answer in this problem only should be 2 significant figures. The way this problem is written right now, I've got 4 significant figures. So I know I'm going to have the 6 and then the number next to it, but then I look at the number that's next to the last significant figure to see if I have to round. It is greater than 5, it's a 6, so that means I need to round that H to a 9 and change the rest of those to zeros. So my final answer for number 2 would be 69,000 foot. If you wanted to write that in terms of scientific notation, apply a decimal point there, moving your decimal points over to write it in scientific notation if you want. You could also express this answer as 6.9 times 10 to the 4. Both of these answers would be acceptable for this problem. So those are 2 examples of how to do unit analysis, unit conversion, and you only needed 1 equivalency to do those problems. In these next 3 problems, we're going to do unit conversions where we need to make use of more than 1 conversion factor. So I really need to actually update this slide because since we have a new Warren Theater in Midwest City now, which unfortunately is not open, but my house is now closer than 15 miles to the Warren Theater. But for sake of the example, we'll leave it like this. But I have 15 miles and I want to know how many micrometers that is. So when I see that, I see, oh, micro, yeah, that's micro, that's that U with the funny little tail. And oh yeah, micro means 10 to the negative 6. And how did I know that? I got that from my SI prefixes chart that we talked about in an earlier video. So just keep that in mind because we're going to use that equivalency later on when solving this problem. But we're going to start this conversion problem just like we did the other two, which is write down the unit, the measurement you're given, number and unit. Give yourself some space to work the problem. Write down the unit that you're looking for. I am looking for micrometers. And looking at the SI prefixes chart and the conversion unit table that was given in the previous slide, you see there's no direct conversion factor or direct equivalency between miles and micrometers. But you do see that I can go from miles to kilometers. That's useful. So I can convert that to kilometers. And hey, kilo. Oh, kilometers. Oh, I see that I've got meters here and meters here. If I could just get my kilometers to micrometers, that would be great. And I can do that using the definition of the prefixes of kilo and micro. I first need to take my kilometers and convert to meters using the definition of the prefix kilo. In 1 kilometer, there's 10 to the 3 meters. And again, I've written that so my kilometers cancel. I'm left with the meters right now in the numerator. I got to get to micrometers. So just one more conversion factor. I need to make use of my definition of micro, which is 10 to the negative 6. In 1 micrometer, there are 10 to the negative 6 meters. Again, writing my units so they cancel. I'm left with the micrometers. That's the unit that I'm looking for, so I can stop setting up my unit analysis problem, and I just need to put this into my calculator. So again, remembering that numbers in the numerator are multiplied, numerators in the denominator are divided. You can think about this as being over 1. When putting that in your calculator and rounding it to 2 significant figures, because remember I have 2 significant figures here, all of these conversion factors are exact numbers, they have infinite sig figures. So this answer, this final answer rounded to 2 significant figures is 2.4 times 10 to the 10. So in this problem, we made use of several conversion factors or equivalencies to do our problem. It'll be a similar situation in number 4, but hopefully you see something different in number 4 that we haven't seen yet in a problem, at least with these first 3. I have a unit with my given that has a unit in the numerator, which in this case is centimeters, and a unit in the denominator, which is seconds. And so I'm going to have to convert both of those to my final unit, which is mph, which is also known as miles per hour. So I'm going to start off this problem again the same way I've done the first 3, but don't be as lazy as I was when writing this first problem. As you can see, I typed it so that the centimeters and the seconds kind of on the same line. When you have a unit that is in the numerator, in the top, and in the denominator, or the bottom for a measurement, when you write that measurement, be very clear as to what unit is in the numerator and what unit is in the denominator. So writing the problem this way is okay, but I like writing it this way so you can clearly see that, oh, centimeters is in the numerator and seconds is in the denominator. And then I'm going to do the same thing with the mph. I'm going to write that down so I can clearly see that miles is in the numerator and hours is in the denominator. So I recommend that you do that, particularly when doing unit conversions with problems that have a unit in the numerator and in the denominator. The next step is to decide which unit am I going to convert first. Am I going to convert my centimeters to miles first? Or am I going to convert my seconds to hours first? Doesn't matter which one you do first, as long as you do one, convert it, and then do the second. And I like to do it all in one long strand so I can easily tell when that problem can stop to give me the answer that I'm looking for. So I decided to do the centimeters to miles first. Looking at that table on the previous slide, you see there's no direct conversion unit between centimeters and miles, but I can go from centimeters to inches. Again, written, so my centimeter units cancel. Left with inches, I can go from inches to feet. Again, written, so my conversion unit cancels. And hey, I'm in feet. I can go from feet to miles by saying 5,280 feet in 1 mile. So my feet unit cancels. I'm left with MI, which is simple for miles in the numerator. Hey, that's what I'm looking for here. I've got miles in the numerator. Got miles in the numerator. So half of this problem, setting up half of this problem, is done because the unit in the numerator matches the unit that I'm looking for in my answer. If I was to stop the problem now, though, and put it in my calculator, my final answer would not be in miles per hour, it would be in miles per second. So I have to change this second that's in the denominator here to hours. I can do that easily by using the definition of seconds and minutes and hours. I know that there's 60 seconds in a minute and 60 minutes in an hour. So when I write that 60 seconds in a minute. I write that with 60 seconds in the numerator, so that seconds unit cancels with this second unit all the way down here. Now I'm left with minutes. I can go from minutes to hours, again having those cancel. And now I'm left with hours in the denominator, which is great because that's what I'm looking for. So again, everything in the numerator multiplied, everything in the denominator divided. My final answer will have a total of 3 significant figures based upon what was shown in the given. So my final answer written to 3 significant figures is 6.71 times 10 to the 8th miles per hour. So we have one more problem we're going to talk about, but I would say that if you feel comfortable doing problems like 3 and 4, as shown here, and problems that are on the Canvas worksheet, posted Canvas worksheet for practice, you should have no trouble with the problems that I give you on the quiz or the exam. But let's do one more problem. I've got something in foot cubed, and I need to go to centimeters cubed. And you may think, oh, we haven't done anything with cubes yet. How are we gonna deal with that? Well, we're going to deal with it in a very similar way as we did the previous problems. Let's first write down what we're given, 0.02500 foot cubed. I'm looking for something that's in centimeters cubed. Now, if I was solving this problem and I just had foot without the cubed, or centimeters without the cubed, I could do that problem. I could go ahead and I could go from feet to inches and inches to centimeters. But how would I deal with the cubed? Let's first, if we go from feet to inches, we know there's 12 inches in a foot. But this foot unit cannot cancel with this foot unit because it's a cube. So I can take care of that by cubing both sides of my conversion factor. Just like in algebra, if you add 2x to one side of an equation, I have to add 2x to the other side of the equation. What you do to one side of an equation, you have to do to another. Same thing with equivalencies. If I cube one part of a conversion unit, then I have to cube the other part. Now my given is already cubed, so I don't have to add another power to the 3. But I do need to cube both the numerator and the denominator for my conversion factor, so I follow correct algebra rules. And so when I do that, my foot cubed unit cancels with that foot cubed unit. I'm left with inches cubed. Then I can use the definition between inches and centimeters to get from inches to centimeters. And then I, again, cube both sides because I need what you do to one side of the equivalency, you have to do to the other. Those units cancel. I am left with centimeters cubed as a unit in the numerator, which is great because that's what I'm looking for. But how do you enter this in your calculator? We haven't done cubes yet. How do we do that? Well, it's going to depend upon which kind of calculator you have. So take a look at your calculator. Some calculators actually have an x cubed button. I've actually seen a few that do that, but more commonly, I have seen calculators have a caret button or a button that says y to the x on it. Either one of these can be used to cube numbers. So if you have a caret button, the way that you would type in this problem up here would be 0.02500. Now you do not need to cube it because it already came cubed. But you type in your given, multiply it by 12, and then this caret tells the calculator you're going to take it to the cubed power. Then you're going to multiply by 2.54 caret and then 3 power. Equal sign. You don't need to divide by anything because 1 cubed is the same as 1. So for a calculator with a caret button, that's how you do a cubed. If you have a y to the x button, very similar, except in place of the caret, you put in the y to the x button. So I've kind of typed down here the order in which you would type in the keys on your calculator to get the final answer. Regardless of how you type it in, if you've got a calculator with a caret button or a y to the x button, my final answer to 4 significant figures, because this given has 4 sig figs, should be 707.9 centimeters cubed. So those are the 5 example problems of unit analysis or dimensional analysis. If you have not tried the ones on the Chapter 2 Canvas worksheet already, I would encourage you to do so and then check your answers on the answer key that I've also posted. And of course, you can always email me with any questions that you have.